Okay, hi everyone. So, Unit 2, Integers and Inequalities. So this is day 1, prime and composite numbers. The idea, the idea is that factors are whole numbers to multiply together or to make a number. Prime, a prime number has exactly two factors, one in itself. A composite number has more than two factors and can be built from smaller whole numbers. Special case, the number 1 has only one factor, so it's neither prime or composite. That's good. Let's have a quick check. Look at the factor pairs for numbers under 100. Test 2, 3, 5, 7. Remember, 2 is the only even prime number. Every other even number greater than 2 is composite. Tip, which is a factor detector tip. List every factor prepared before you decide. Model the example. 17, like factors of 17, 1 and 17. 17 has exactly two factors, so it's prime. I don't know why this.
Employers don't hire diplomas, they hire skills. At WGU School of Technology, you'll earn both, with a degree backed by industry certifications that prove you're job ready. Learn more at wgu.edu.
Welcome to Math with Mr. J. In this video, I'm going to cover what prime and composite numbers are. And up top, we have the definitions of each. And then below at the bottom, we have 6 different examples or problems that we're going to go through together in order to get this down. Now for numbers 1, 2, and 3, we're just going to determine if those are prime or composite. And then for numbers 4, 5, and 6, we're going to pick out which ones are prime out of the list of 4. And number 4, there is going to be one prime number out of the 4. In number 5, there's one number out of the 4. In number 6, there are going to be 2 prime numbers out of the 4. So let's go into our definitions here and then go through our examples. So a prime number is a whole number with only 2 factors, 1 and itself. And we'll see what that means here in a second. And a composite number means that there are factors other than 1 and itself. And again, we'll figure out what that means here in a second. So number 1, we have a 6. We need to determine if that's prime or composite. So let's think of all the factors of 6. Which numbers can we multiply together to equal 6? So I know that I can do 1 and 6 to equal 6, right? 1 times 6 or 6 times 1. Any other numbers that can go into 6? Well, I know 2 and 3 as well. So this 6 has factors other than 1 in itself. We have a 2 and a 3 here as well. So it's automatically composite. A prime number will only have 1 and itself as the factors. Number 2, 24. Well, we know 1 and 24, and 24 actually has a lot of factors or numbers that can multiply to get 24. So we know 2 and 12 can multiply to get 24, 3 and 8, and 4 and 6. So we have a lot of different factors there for 24. So this one is easily composite. Number 3, 7. So let's think of the factors of 7. Which multiplication facts or numbers can we multiply together to give us 7? And actually it's only 1 and 7. 1 times 7 or 7 times 1. So this only has two factors, 1 and itself. So 7 is prime. Number 4, let's go through all 4 choices and find the prime number. So 18, well, this is even, and we automatically know that 2 can go into all even numbers. So all even numbers, except for one special one, are going to be composite. So 18 is composite. I'll put a C here because we know 1 times 18, 2 times 9, 3 times 6. So we have a lot of different factors there. So composite. 9, well, 1 times 9 is 9. And we can also do 3 times 3. So we have 3 factors for 9. And that means it's composite because it's more than 1 and itself. Now, a common misconception when people start looking at prime and composite numbers for the first time are thinking that all evens are composite and then all odds are automatically prime, which isn't true. Odd numbers can be composite, just like this 9 here. 4, well, 1 and 4, and then also 2. 2 times 2, right? So 4 is composite. And then the last one, this is going to be our prime number. The only factors of 13 are 1 and 13. So 13 is our prime number there. Let's take a look at number 5. 15, again, don't just think because it's odd that it's going to be a prime number. 1 and 15, also 3 and 5 are factors. 5 times 3 or 3 times 5 equals 15. So 15 is composite. Now 5 on the other hand, the only factors of 5 are 1 and 5. So 5 is prime. 18, composite. 33 almost seems like it would be prime. 1 and 33, but we can divide 33 by 3 and get 11. Or think of our multiplication facts, 3 times 11 equals 33. So 33 is composite. And number 6, we have 2 prime numbers here. The first one being this 29. The only factors of 29 are 1 and 29. So we have a prime number here. 34 is even, so we know that it's going to have more than just 1 and itself. So we have 1, 34, 2, and 17. So 34 is composite. Next we have 2, which is kind of a special number here because it's the only even number that's prime. 2 only has 2 factors, 1 and itself, 1 and 2. So again, 2, the only even number that is actually prime. Then we have 21. Well, let's think. We have 1 and 21, and then also 3 and 7 as factors. So 21 is composite. So there you have it. There's the prime and composite number video. Hopefully that helped. Thanks so much for watching. Until next time, peace.
Okay, the next one. This is the practice. Number 1, list the factors of 13 is 13 prime and composite. Number 2, list the factors of 18 is 18 prime and composite. Number 3 is 1 prime prime composite or neither. Number 4, which are prime? 2, 9, 11, and 21. And then work on this with your teacher partner for your reasoning. It's the homework for prime and composite numbers. Number 1, classify 23 as prime or composite, explain. 2, classify 25 as prime and composite, explain. And number 3, classify the 37 as prime and composite. And 4, classify 51 as prime and composite. 5, which numbers neither prime nor composite. 6, circle all prime numbers. 7, 15, 19, 27, and 31. Answer keys on the next slide. So this is the answer key. Number 1 is prime. Factors from 1 is 23. Number 2 is composite. Factors from 1, 5 is 25. Number 3 is prime. 4 is composite. 3 times 17 is 51. Number 5 is 1. Number 6 is 7, 19, and 31. If you missed one, explain the correction. Day 2, the greatest common divisor, GCD. Math notes, key idea. Factor divides a number evenly with no remainder. Common factor is a factor that two numbers share. GCD is greatest common factor, is the largest factor shared by both numbers. Step 1, list all factors of each number in order. Step 2, circle all factors that appear in both lists. Then choose the greatest one. When to use it, use the GCD to make the greatest number of equal groups with nothing left over. Also, tip, always check over your answer. The GCD must divide both numbers evenly. Okay, this is a modeled example of GCD. Greatest common divisor. Of 18 and 24, 18 is 1, 2, 3, 6, 9, 18. 24 is 1, 2, 3, 4, 6, 8, 12, and 24. The greatest common factor.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
Welcome to Math with Mr. J. In this video, we're going to discuss how to find the greatest common factor between two numbers. And as you can see, there are four problems here and sets of numbers that we're going to find the greatest common factor. So for example, number 1, we have 10 and 15. So let's jump right into that one and see how we find the greatest common factor. Well, before we find the greatest common factor, we need to know what factor means. And factors are all the numbers that can multiply together to give you that number. So let's make sense of this. So we have 10 here. We're going to list all the factors of 10. And like I said, it's all the numbers that can multiply together to give you 10. So for every number, when you're listing the factors, you can start with two things. 1 and that number itself. And I'm going to put some space in between for the other factors. These are a factor pair here because I can do 1 times 10 equals 10, or 10 times 1. That's a multiplication fact that gives me 10. So those are factors. Can you think of any other pairs that will equal 10? Hopefully you're thinking 2 and 5, right? 2 times 5 is 10, or 5 times 2 is 10. So I fill in my space here with the 2 and the 5. And 10 has 4 factors, 1, 2, 5, and 10. 2 and 5 are a pair as well. If you want to connect them, if that helps you out, that works. So let's do 15. So we need to think of the factors of 15. So we always start with 1 and the number itself, and leave some space in between for your other factors. Now, once you get better at this, you will get very good at the spacing. When you're first starting out, you may have trouble spacing out in between there where you can put your factors. That's fine. As long as you have all your factors listed, don't worry so much about the spacing. So 1 and 15. Now sometimes if the number's prime, you'll only have a 1 and that number itself. That's exactly what prime means. But composite numbers means you have more than just 1 and the number itself. And 15 is composite. So can we think of any other factors for 15? Hopefully we are thinking 3 and 5, right? 3 times 5 is 15. So 3 and 5 are a pair, 1 and 15 are a pair, and there aren't any more, so we're done. So now we need to find the greatest common factor. So the greatest one that they have in common. So I see that they have 1 in common, and they also have 5 in common. So what's the greatest? Well, 5. So we can put GCF, greatest common factor, equals 5. All right, let's try number 2 here. So we have 12 and 6. Let's start with our factors of 12. So we start with 1 and 12. Well, 12's even, so I know 2 is going to be a factor. And you can think, well, what's 2's partner? Well, 6. 2 times 6 gives me 12. So put my 6 here. And there's one more pair, or 2 more factors for 12. And it's 3 and 4. And that's it for 12. Now let's write our factors for 6. So we always start with 1 and the number itself. 6 is even, so I know 2's automatically going to be a factor, and 2's partner, or other factor for 6, is 3 here. So there's your list of factors for 6. So I see they have 1 in common. And sometimes that will be your answer for greatest common factor. Not for number 2 here. Well, speaking of 2, they have 2 in common, 3 in common, and they also have 6 in common. So they have a lot of common factors, but we want the greatest. So the GCF for 12 and 6 is going to be 6. All right, number 3 and 4 here. If you feel comfortable enough to try a couple on your own, feel free to press pause, finish 3 and 4, and then when you're ready, press play and check your work with mine. If you want to do 3 and 4 with me, and 10. So we'll start with 1 and 20. And I know that 20 is even, so 2 is going to be a factor, and its partner's 10. Any others? Well, 4 and 5. And that's actually it for 20. So let's do 10. 1 and 10. And when you get into greatest common factors, one thing you should look for is if you already have a list of something, use it. Notice I have all my factors listed. 2, they have 5 in common, and then they have 10 in common. So the GCF is 10 for 20 and 10. Odd numbers here, 9 and 21. So let's write, and then is there anything else that we can multiply to get 9? Well, 3 times 3, so 3 is a factor. You only need to write 3 once though. 21, we'll start with 1 and 21. Now, are there any factors of 21 other than 1 and 21? Yes, 3 times 7. So there are our factors for 9 and 21. They have 1 in common, and they also have 3 in common. So the GCF, or greatest common factor, is going to be 3. So there. Until next time.
Okay. So this is the practice number 1. Find the GCD. It's 12 and 18. Number 2, find the GCD. 20 and 30. Number 3, find the GCD. 16 and 24. Number 4, find the GCD. 24 red beads and 36 blue beads go into identical groups. Greatest number of groups. Work with your teacher or partner and go reason. So homework for day 2. Greatest common divisor. Number 1, find the GCD. 15, comma 25. 2, find the GCD. 18, comma 30. 3, find the GCD. 28, comma 42. 4, find the GCD. 32, comma 48. Number 5, find the GCD. No, it does not say find the GCD. It's 20 pencils and 30 erasers are packed into identical sets. Greatest number 6. Teacher has 36 apples and 40 oranges. Greatest number of beds. Answer keys on the next slide. Number 1 is 5, number 2 is 6, number 3 is 14, 4 is 16, and 5 is 10 sets, 6 is 12 beds. This one is spent correction words. least common multiple, LCM. It's just like a learning target. It might be on every side, might not. I can find least common multiple of two whole numbers. Mathematics give the key idea. A multiple is the result of multiplying a number by 1, 2, 3, and so on. The common multiple appears in multiple sets of both numbers. LCM is the least common multiple. It's the smallest possible multiple. The number shared. Step 1, write several multiples of each number in order. Step 2, find the first number that appears in both sets. Want to use LCM when events repeat, and you need to know when they happen together again. Big tip, do not mix them up. GCD uses factors, LCM uses multiples. Modeled example. LCM of 4 and 6, multiples of 4 is 4, 8, 12, 16. Multiples of 6, 6, 12, and 18. First common multiple is 12.
Story time about my first horrific SAT experience while I study for the SAT. You guys want to follow along and use the same
Welcome to Math with Mr. J. In this video, I'm going to cover least common multiple, also known as LCM. Least common multiples are commonly used when working with fractions as well as other types of math problems, so least common multiples show up in a variety of situations. Now, when we're talking about least common multiples, let's break that down and think about what this means. Well, least means the smallest in value. Common, in this case, means that something is being shared. And then multiple, well, we get a multiple of a number when we multiply that given number by an integer. Think multiply or skip count when you think of multiples. Now that may sound a little confusing, but it's actually not too bad. I think an example will make it much more clear. So let's jump into number 1, where we have 3 and 6. Let's start with some multiples of 3. And remember, think multiply or skip count. So let's write the first 5 multiples of 3, and then we'll go from there. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So I'll stop there, and then we'll write some multiples of 6 and see if we have any in common. And if we do, we're going to look for the least that they have in common. Now, those multiples go on forever. So I suggest writing 4 or 5 multiples for each given number, see if you have any in common, and then go from there. You can always extend your lists of multiples. So let's write some multiples of 6. So again, think multiply or skip count. So 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, times 4 is 24, and then times 5 is 30. So we did 5 multiples for each. Let's see if we have any common multiples. So we have 12 in common, and we also have 6 in common. But we want the least. So 6 is going to be the least common multiple between 3 and 6. So I'll put LCM, which stands for least common multiple, equals 6. Let's try another example and move on to number 2, where we have 4 and 10. So we'll start with some multiples of 4. So skip count, or think of it as 4 times 1, 4 times 2, so on and so forth. Let's skip count for this one. So 4, 8, 12, 16, 20. So we'll write 5 for that one. Let's do 10 now. 10, 20, and you may notice that we have something in common there, and that's going to be the least common multiple. If you notice that you have a least common multiple, there's no need to keep writing out multiples. We have our answer. So 20 is going to be our least common multiple. So least common multiple equals 20. Let's move on to number 3, where we have 9 and 6. So we'll start with some multiples of 9 here. So 9, 18, 27, 36, 45. And now some multiples of 6. 6, 12, 18, and we have our least common multiple right here, which is going to be 18. So our LCM equals 18. Now I do want to mention before moving on to number 4 that for these problems we're going to have an infinite amount of common multiples. Since we have an infinite amount of multiples, we're therefore going to have an infinite amount of common multiples. We can always extend our lists further in order to find more common multiples. But since we want the least, we need to focus on that least, and once we have that least common multiple, we have our answer. Let's move on to number 4, where we have 12, 4, and 8. So we have 3 numbers, and we need to find the least common multiple between all 3. Let's start with some multiples of 12. So 12, 24, 36, 48, and 60. Let's do 4 now. So 4, 8, 12, 16, and 20. And lastly, 8. So 8, 16, 24, 32, and 40. So as we look at these lists, we do have some common multiples, but we don't have any common multiples between all 3. And we need a common multiple between all 3, and specifically the least common multiple. So what we can do, we can extend our lists until we find that least common multiple. Now the 12s, the multiples of 12, we're already at 60. So let's leave that list. Let's look at the 4. We're only at 20 there. So let's extend the lists of multiples for 4. So our next multiple is going to be 24. And that's going to be our least common multiple. 24, 24, and 24. So if you don't see a least common multiple, you can always extend your lists until you find it. So for number 4, our LCM equals 24. So there you have it. There's how you find the least common multiple. Peace. So much for watching. Until next time, peace. So much for watching. Until next time, peace. Thanks so much for watching. Until next time, peace.
Okay. Next one is the practice. Number 1, find the LCM 3, 5. Number 2, find the LCM 4, 10. Number 3, find the LCM 6, 8. Number 4, legs blink every 4 seconds and 6 seconds. One with they blink together. By the way, for each practice, you guys can work with your teacher or partner, or even by yourself. Just remember to show your reasoning. Okay. Number 3, homework. Number 1, find the LCM 2, 7. 2, find the LCM 5, 6. Number 3, find the LCM 8, 2. Number 4, find the LCM 9, 15. Number 5, one bus comes every 10 minutes and another every 15 minutes. Together again in what time? Number 6, 2 times beep every 6 minutes and 14 minutes. Together again in portion. Answer keys on the next slide. Number 1 is 14, number 2 is to 30, number 3 is 24, number 4 is 45, 5 is to 30, 6 is 42 minutes. Oh yeah, by the way, number 5 is 30, and then number 6 is 42. Okay, this is day 4, read inequalities from number line graphs, learning target. Combine an inequality that matches a number line graph. Math notes, endpoint, this circle shows the boundary number where the graph begins. Open circle, the endpoint is not included, so use less than or greater than. Closed circle, the endpoint is included, so use less than or equal to, greater than or equal to. Shade left, the solutions are less than endpoint. Shade right, the solutions are greater than the endpoint. Read the graph first, check the circle, then follow the shaded arrow. And finally write the variable and submit. Okay. Quick tip, which is a memory trick. Left means less, right means greater. Model example, graph, closed circle 3, shade right, closed, which includes 3. But yeah, x is greater than or equal to 3, right is greater than.
I'm in high school and I have absolutely no idea what I want to do for my career. And that's what I would have said if I never used Futurescape.
Welcome to Math with Mr. J. In this video, I'm going to cover how to write inequalities from number lines. And we have 4 examples that we're going to go through together in order to get this down. Now remember, when it comes to inequalities, a filled circle means that number is included in the solutions. An open circle means that number is not included in the solutions. So let's jump into number 1, where we have a filled circle above 2. So we know 2 is going to be included in our solutions. We have an arrow pointing to the right, which means that any number greater than 2 is going to be a solution as well. And the arrow represents the infinite amount of solutions there as far as numbers greater than 2. So we are going to use x to represent our solutions. And again, we want to include 2 and then anything greater than 2. So x is going to be greater than or equal to 2. Now you can write that inequality starting with 2 and saying 2 is less than or equal to x. Both of those inequalities mean the same thing. The order is just different. Obviously, we have the x first in the first one and the 2 first in the second one, but they are both saying the same thing and represented by the same graph on a number line. So on to number 2, where we have an open circle above -1. So -1 is not going to be included in our solutions. The arrow is pointing to the left, so we want all the numbers less than -1. So we'll use x again. X is going to represent our solution, so x has to be less than -1. And -1, again, is not included because of the open circle. So we do not want an or equal to symbol for this inequality. So x is less than -1. Any number less than -1 would be a correct solution. And we have an infinite number of correct solutions as far as that inequality goes, and that arrow represents that. Now we can also write that inequality starting with -1 and saying -1 is greater than x. Again, both of those inequalities mean the same thing. The order is just different. On to number 3, where we have an open circle above 58. So 58 is not included in our solutions. And the arrow is pointing to the left, so we want all of the numbers that are less than 58 as far as solutions go. So x is going to be less than 58. Or we could say that 58 is greater than x. And lastly, number 4, we have a filled circle above 12, so 12 is going to be a solution. We have an arrow pointing to the right, so we want all of the numbers greater than 12 to be represented for solutions within our inequality. So we will write x, and x is going to be greater than or equal to 12. Or we could say that 12 is less than or equal to x. So there you have it. There's how you write inequalities from number lines. I hope that helped. Thanks so much for watching. Peace. Thanks so much for watching. Until now, number lines. I hope that helped. Thanks so much for watching. Until next time, peace.
Okay, this is the practice number 1. Open circle at 4. Try each problem, explain. I know. Open circle at 4. Shade left, right the inequality. Number 2, close circle at -2. Shade right the inequality. And number 3, close circle at 7. Shade left, right the inequality. Number 4, open circle at 0. Shade right the inequality. Okay, number 4 homework. Day 4 homework. Number 1, open at 5, shade right. Number 2, closed at -1, shade left. Number 3, open at 2, shade left. Number 4, closed at 6, shade right. Number 5, which symbol matches an open circle, shade left. Number 6, which symbol matches a closed circle, shade right. Answer keys on the next slide. Okay, so number 1, x is greater than 5. And then number 2, x is less than or equal to -1. Number 3, x is less than 2. 4, x is greater than or equal to 6. Number 5 is less than. Number 6 is greater than or equal to. Okay, number 5, day 5, write inequalities for constraints. Learning target, I could write a one variable inequality from a rule or limit. Math notes constraint. A constraint is a rule or limit that tells which values are allowed. Step 1, choose a variable and tell what it explains. Number 2, fill in the binary number in the sentence. At least or more, greater than because the binary value is included. At most, no more, less than because the binary value is included. More than, less than, use greater than or less than because the binary value is not included. Okay. Quick tip. Circle the clue words for choosing inequality. Some model example. Rule: it must be at least 48 inches tall. Let h equal height in inches, at least meaning greater than or equal to. Inequality: h is greater than or equal to 48.
If English isn't your first language like me and you want your writing to reflect your voice, consider trying Grammarly Pro today to elevate.
Welcome to Math with Mr.
This is the introduction to inequalities.
J. In this video, I'm going to cover the basics of inequalities. Now, an inequality is a comparison between two values, numbers or expressions that are not equal. But sometimes there is a possibility of the values being equal depending on which inequality symbol is being used. You'll see exactly what I mean as we go through our examples. The 5 symbols used to represent inequalities are not equal, greater than, less than, greater than or equal to, and then less than or equal to. So let's jump into number 1, where we will take a look at what all these symbols actually mean. And we'll start with x equals 10, which is not an inequality, it's an equation. So x equals 10, this is an equation. Now there's only one solution for this equation. X has to equal 10. No other solutions will make this equation true. For example, if we were to plug in x equals 9, well, let's put a 9 here. Would 9 equal 10? No. The only thing that x can equal is 10. 10 equals 10. So I wanted to include an equation so we could compare this to the inequalities. Now for number 2, we have x is greater than 10. Now remember, you always want the wider side, the open wider side of an inequality symbol facing the greater value. So x is greater than 10 here. So any number greater than 10 would be a solution for that inequality. There's an infinite amount of correct solutions. So for example, 11 would work, 50 would work, or 150. It doesn't matter. Anything greater than 10 would be a solution for x, for that inequality. Now 10 would not be a solution because x has to be greater than 10. Is 10 greater than 10? No. Now the third inequality down right here is x is greater than or equal to 10. So all of those solutions we talked about for x is greater than 10, 11, 50, 150, anything greater than 10 would be a correct solution, just like the one above. But this one, 10 is a correct solution as well. So 10 would work for this because 10 is greater than or equal to 10. So when we talked about the possibility of the values being equal, when we have that or equal to, we can have an equal solution there to the given value. So just to recap, these two inequalities right here, any number greater than 10 would be a correct solution. But they differ because the bottom one here, 10 is included in the correct solutions because we have x is greater than or equal to 10. So let's move on to this inequality right here where we have x is less than 10. So any value less than 10 would be a correct solution. So 1, 2, 8, -8, whatever the case may be. Again, we have infinite solutions to that inequality. Now 10 would not be a correct solution. 10 is not less than 10. But for this inequality here, we have x is less than or equal to 10. So 10 would work for this one, but not the top one. So you can see the difference between the less than sign, x is less than 10, and then the x is less than or equal to 10. So again, these two inequalities right here, any value less than 10 would be a solution, but the less than or equal to, we can include 10 in those solutions. And then lastly, we have x is not equal to 10. So any value that's not 10 would be correct there. So 8, 9, -20, whatever the case may be, the only incorrect solution would be if we were to put 10 in there. Is 10 not equal to 10? No, that doesn't make sense. So any value other than 10 would work for that last inequality. So let's jump over to numbers 2, 3, and 4 and come up with some correct solutions to those inequalities. So number 2, we have 7 is less than j. So any value greater than 7 there, because j, that side has to be greater than 7. So anything greater than 7 would work. So we could do 8, 52, or 100. Again, an infinite amount of solutions there, so anything greater than 7 would work. Now 7 is not included because that is just a less than sign. It's not an or equal to. Now number 3, we have 11 is greater than or equal to a. So for a, solutions could include anything less than or equal to 11. So 11 would be a solution because we have or equal to. And then anything less than 11. So it could be -1 or let's do 3. So infinite amount of solutions, anything less than 11 or equal to 11 would work there. And lastly, number 4, we have y is less than 5. So this is just a less than sign, so 5 is not included in the solutions. So anything less than 5. So we could do -9, 0, or 1. And then that list goes on forever because we have an infinite amount of solutions for values that are less than 5. So there you have it. There are the basics of inequalities and what those symbols mean. I do have other videos expanding on the topic of inequalities. I'll drop all of those links down in the description. Peace. Thanks so much for watching. Until next time, peace.
Okay, here's the next one, the J5 practice. Number 1, a backpacker can hold at least at most 48 lbs. Let W equal weight. Number 2, you need more than 70 points. P is equal to points. Number 3, a child tickets for ages less than 12. Let A equal age. Number 4, you must read at least 30 pages. P equal pages. Work with your teacher or partner. Show your reasoning. J5 homework. Write inequalities for constraints. Number 1, a room holds at most 40 people. Let P equal people. Number 2, a game requires more than 100 coins. Let C equal points. Number 3, a package must weigh less than 15 kgs. So let W equal weight. 4, you need at least 8 hours of practice. Let H equal hours. 5, a rod is for heights 52 inches or taller. Let age equal height. Number 6, a coupon works for purchases under $25. Let P equal purchase. Answer keys on the next slide. 1, P is less than or equal to 40. Number 2, C is greater than 100. Number 3, W is less than 15. And then 4, H is greater than or equal to 8. Number 5, H is greater than or equal to 52. 6, P is less than 25. If you missed one, explain the correction you used. Okay, this is day 6. Create real life situations and graphs. Math notes to talk out words, either inequality aloud or creating a story or graph. Oh yeah, also the learning target is that I can create a situation for a number line graph for given inequality. Okay, so yeah, we would just finish it. First line. Okay, let's go to the next one. Choose a quantity. So use something that makes sense, such as age, height, time, points, cost. Match the boundary. The number and situation must be the same boundary showing the inequality. Match a circle. Use a closed circle, like less than or equal to, greater than or equal to an open circle for greater than or less than. Match a direction showing left for less values and right for greater values. Final check. Ask whether every value on a graph would make sense in a real life situation. Tip: a correct story, symbol, circle, and arrow must all tell the same. Model the example to use less than or equal to 10. Situation: the trip takes at most 10 minutes. Graph: the whole circle 10. Social left.
The speed of sound is approximately 768 miles per hour. When an object travels faster than the speed of sound, it creates a sonic boom. And there's actually a whole video on how sonic booms are created on Khan Academy. I encourage you to watch it. It's actually fascinating. But anyway, back to this question. Write an inequality to represent S, the speeds at which a moving object creates a sonic boom. So let's write an inequality. Let's do what they told us to. S, let's see, S has to be, they say, when an object travels faster than the speed of sound. So our speed has to be greater than the speed of sound. Our speed has to be greater than the speed of sound, which is 768 miles per hour. So S has to be greater than 768. Now, another way we could have written that is that 768 needs to be less than S. We could have written 768 needs to be less than S. That's another way we could write it. In either case, our speed is going to be greater than 768 miles per hour. We'll check our answer. Let's do a few more of these. To cook a steak to medium rare, it needs to have an internal temperature of 135 degrees Fahrenheit. A lower internal temperature will undercook the steak. Write an inequality to represent all of the possible temperatures T of an undercooked steak. Well, to be an undercooked steak, your temperature is going to be less than 135 degrees. So your temperature, T, is going to be less than. You could either just use the less than on your keyboard, or you could click over here on less than. Your temperature is going to be less than 135. We're assuming that your temperature is in Fahrenheit degrees. So your temperature needs to be less than Fahrenheit, less than 135 degrees if you are going to have an undercooked steak. So we got that one right. Let's do a couple more, or one. Let's do one more. Simone is going snowboarding tomorrow if the temperature is equal to or colder than 5 degrees Celsius. Write an inequality to represent the temperatures at which Simone will go snowboarding. So you might want to say you might want to say, oh, well, maybe, T is less than 5 degrees. Remember, they're telling us that the temperature is equal to or colder, so she's even willing to go snowboarding if it's less than or equal to 5 degrees. So instead of just saying less than, let's say less than or, let's say less than or equal to 5 degrees. So this inequality represent here, this shows us all of the temperatures at which she is willing to go snowboarding. Check our answer, and we got it right.
Practice number 1, create a real-life situation for n is greater than 6. Number 2, describe the graph for x is less than or equal to 4. Number 3, create a real-life situation for h is greater than or equal to 48. 4, describe the graph for n is less than 4. Work with your teacher or partner and show these. Try each problem and explain how you know it. So, day 6 homework, create a real-life situation graphs. This one you have to complete independent. All the homeworks you have to complete independently, by the way. Show work when needed. Number 1, complete it. Complete. So number 1, create a situation for x is greater than or equal to 5. Number 2, create a situation for t is less than 30. Number 3, describe the graph for t is greater than 9. Number 4, describe the graph for w is less than or equal to 18. Number 5, create a situation for t is less than or equal to 20. 6, create a situation for a is greater than 20. Answer keys on that slide. Example number 1, example, you need at least 5 books. Number 2, you need example. Example, its time must be less than 30 minutes. Number 3, open circle at 9, shade right. 4, close circle 18, shade left. Number 5, example, you must use at most 20. You may use at most 20 cards. 6, example, age must be greater than 12. If you miss one, explain the correction words. Today's 7 check solutions learning target. I can use substitution or Nephilim graph to check whether a value makes an equality to 2. Method of solution. A solution is any value that makes an equality to 2. Step 1, replace the value with the number you're testing. Step 2, read script in comparison left to right. Step 2, decide whether the statement is true or false. True, the tested number belongs to the solution set. False, the tested number does not belong to the solution set. You can also check the condition of the graph. Quick tip. Add special touch to the endpoint when the symbol includes equal to. This 7 is solution to x is less than or equal to 9. Substitute 7 less than or equal to 9. That demonstrates 7 is a solution. Working. Screen's working.
Love Roblox? Earn Roblox digital gift cards with Microsoft Rewards.
Welcome to Math with Mr. J. In this video, I'm going to cover the basics of inequalities. Now, an inequality is a comparison between two values, numbers or expressions that are not equal. But sometimes there is a possibility of the values being equal depending on which inequality.
Honestly, this is the easy units. Yeah, this is basically the same one as that. So we'll just move on to the practice. Number 4 is 4 a solution to x is greater than 2. Number 2 is 6 a solution to n is less than or equal to 5. Number 3 is minus 3 a solution to y is greater than or equal to minus 3. Number 4 is 10 a solution to p is less than 10. Work with the teacher partner and show these. This one complete independently. And show work when needed. And then number 1 is a solution to x is greater than or equal to 5. Number 2 is 3 solution to x is greater than 3. 3 is minus 4 a solution to x is less than or equal to minus 2. Number 4 is 12 a solution to p is less than 15. Number 5 is 0 a solution to y is greater than or equal to 1. Number 6 is 7 solutions and is less than or equal to 7. Answer keys on the next slide. Number 1 is yes, number 2 is no, number 3 is yes, number 4 is yes, number 5 is no, 6 is yes. Okay. Let's see if I record. Yeah. Okay. Okay. Number 8. Identify values in the solution set. Learning target. I can identify which values belong to the solution set of inequality. Method of the solution set. The solution set contains every value that makes the inequality true. Method 1. Substitute each listed value and check whether the statement is true. Method 2. Compare each value directly with the boundary value. Include the endpoint. Use the boundary value when the symbol is less than equal to or greater than equal to. Do not include it. Leave out the boundary value when the symbol is less than. Big idea, and inequality usually has many solutions, and many have infinitely many solutions on a number. Quick tip: test every choice. Don't stop after finding just one solution. Some model example: inequality. X is greater than 4. Choices 2, 4, 5, 7. 5 and 7 are greater than 4. Solution was 5, 7.
So we have two inequalities here. The first one says that x plus 2 is less than or equal to 2x. And this one over here in, I guess this light purple mauve color is 3x plus 4 is greater than 5x. Now over here we have 4 numbers, and what I want to do in this video is test whether any of these 4 numbers satisfy either of these inequalities. So I encourage you to pause this video and try these numbers out. Does 0 satisfy this inequality? Does it satisfy this one? Does 1 satisfy this one? Does it satisfy that one? So I encourage you to try these 4 numbers out on these 2 inequalities.
Okay, so guys, want you guys to just find out.
So assuming you have tried that, so let's work through this together. So let's say, so if we try out 0 on this inequality right over here, let's substitute x with 0. So we'll have 0 plus 2 needs to be less than or equal to 2 times 0. Is that true? Well, on the left-hand side, this is 2 needs to be less than or equal to 0. Is that true? Is 2 less than or equal to 0? No, 2 is larger than 0. So this is not going to be true. So this does not satisfy the left-hand side inequality. Let's see if it satisfies the right-hand side inequality, or this inequality right over here. So in order to satisfy it, 3 times 0 plus 4 needs to be greater than 5 times 0. Well, 3 times 0 is just 0. 5 times 0 is 0. So 4 needs to be greater than 0, which is true. So it does satisfy this inequality right over here. So 0 does satisfy this inequality. Now let's try out 1. Let's try out 1. So to satisfy this one, 1 plus 2 needs to be less than or equal to 2. See, 1 plus 2 is 3. Is 3 less than or equal to 2? No, 3 is larger than 2. So this does not satisfy the left-hand inequality. What about the right-hand inequality right over here? So 3 times 1 plus 4 needs to be greater than 5 times 1. So 3 times 1 is 3 plus 4. So 7 needs to be greater than 5. Well, that's true. So both 0 and 1 satisfy 3x plus 4 is greater than 5x. Neither of them satisfy x plus 2 is less than or equal to 2x. Now let's go to the 2. I know it's getting a little bit unaligned, but I'll just do it all in the same color so you can tell. So let's try out 2 here. So 2 plus 2 needs to be less than or equal to 2 times 2. So 4 needs to be less than or equal to 4. Well, 4 is equal to 4, and it just has to be less than or equal. So this satisfies this inequality. What about the right? What about this purple inequality? So let's see. 3 times 2 plus 4 needs to be greater than 5 times 2. So 3 times 2 is 6 plus 4 is 10, needs to be greater than 10. 10 is equal to 10. It's not greater than 10. So it does not satisfy. It does not satisfy this inequality. If this was a greater than or equal to, then this would have been a greater than or equal to, and it would have satisfied it. But it's not. 10 is not greater than 10. It's greater. It would satisfy greater than or equal to because 10 is equal to 10. So 2 satisfies the left-hand one, but not the right-hand one. All right, let's try out 5. So 5 over here, 5 plus 2 needs to be less than or equal to 2 times 5. Once again, everywhere we see an x, we replace it with a 5. So 7 needs to be less than or equal to 10, which is absolutely true. 7 is less than 10, so it satisfies less than or equal to. So 5 satisfies this inequality. And what you're probably noticing now is that an inequality can have many numbers that satisfy it. In fact, they often have, sometimes they'll have nothing that satisfies it, and sometimes they might have an infinite number of numbers that satisfy it. And you see that right over here. We're just testing out a few numbers. And for this left one, 0 and 1 didn't work, 2 and 5 did work. Now this right one, 0 and 1 worked, 2 didn't work. Let's see what 5 does. So in order for 5 to satisfy it, 3 times x, now x is we're going to try out for 5, we're going to try x being 5, 3 times 5 plus 4 needs to be greater than 5 times 5. 3 times 5 is 15, 15 plus 4 is 19, 19 is to be greater than 25, it is not, so 5 does not satisfy this inequality right over here. So anyway, hopefully you found that fun.
Yeah. Let's go to the next one. Okay. See if I'm recording so far. This is day 8. Guided practice. So probably problem explain I know. And number 1, x is less than or equal to 3, which are solutions 1, 3, 4, 6. 2, x is greater than -1, which are the solutions -3, -1, 0, 2. Number 3, p is greater than or equal to 5, which are solutions 4, 5, and 8. Number 4, for t is less than 10, which are solutions 9, 10, 11. Work with your teacher or partner. Show your wisdom. Day 8 homework. I identify values in a solution set. Number 1, for x is greater than 6, solutions 4, 6, 7, 9. 2, for y is less than or equal to 0, solutions -2, 0, 1, 3. Number 3, n is greater than or equal to -4, solutions -6, -4, -1, 2. Number 4, for t is less than 12, solutions 8, 11, 12, 15. Number 5, for a is greater than or equal to 10, is 10 included. Number 6, for b is less than 5, is 5 included. Answer keys on the next slide. Number 1 is 7, 9. Number 2 is -2, 0. Number 3 is -4, -1, 2. Number 4 is 8, 11. Number 5 is yes. Number 6 is no. If you missed one, explain correction words. Okay, this is just like a unit review checklist with teachers. If you want, you can just print it out, or you could just ask students. It's like check each box out. Ready? So equals I can explain why, not just have an answer. It's like you have to explain it, not only just have an answer. Okay. Okay. Thank you. If you guys have any questions, please mention it to the directors and they'll just ask me. Or like what should I improve on? Okay, so bye.